Welcome back to the part 2 video on rectangles. On Monday we looked at a theorem stating that if a parallelogram is a rectangle, then its diagonals are congruent. Today we'll be determining whether parallelograms are rectangles by looking at the converse of that theorem. Our only theorem today states that if the diagonals of a parallelogram are congruent, then the parallelogram is a rectangle. So if segment WY is congruent to segment XZ in parallelogram WXYZ, then parallelogram WXYZ is a rectangle. It's important to note that the diagonals must be the diagonals of a parallelogram and not just diagonals. So look at this first picture. We have congruent line segments. In the second picture, the diagonals intersect each other and are still the same length. In our third picture, the diagonals are still congruent, but the figure is obviously not a rectangle. So in order to apply this theorem, the figure must first be a parallelogram. So if the diagonals of a quadrilateral are congruent, then the quadrilateral is a rectangle. True or false? Real world example 3. Some artists stretch their own canvas over wooden frames. This allows them to customize the size of the canvas. In order to ensure that the frame is rectangular before stretching the canvas, an artist measures the sides and the diagonals of the frame. If AB equals 12 inches, BC equals 35 inches, CD equals 12 inches, DA equals 35 inches, BD equals 37 inches, and AC equals 37 inches, explain how an artist can be sure that the frame is rectangular. In order to prove the frame is rectangular, what must we first show about quadrilateral ABCD? We must first prove that ABCD is a parallelogram. How can we do that with our given information? So with our given information, which theorem of parallelograms can we use to show ABCD is a parallelogram? Since segment AB is congruent to segment CD, and segment BC is congruent to segment DA, opposite sides of this quadrilateral are congruent, and therefore ABCD is a parallelogram. Since ABCD is a parallelogram, how do we know the frame is rectangular? We know that the measure of AC is equal to the measure of BD, which means that diagonal AC is congruent to diagonal BD. Since ABCD is a parallelogram with congruent diagonals, ABCD is indeed a rectangle. In this example, we're given that Max is building a swimming pool in his backyard. He measures the length and width of the pool so that opposite sides are congruent. He also measures the diagonals of the pool to make sure that they are congruent. How does he know that the measure of each corner is 90? We can see that STUR is a quadrilateral, and it says he has measured the sides and the diagonals, so he knows that they are congruent. Since STUR is a quadrilateral and the diagonals are congruent, what is our next step? It isn't stated that STUR is a parallelogram, so we need to prove that STUR is a parallelogram before we can do anything. What theorem or postulate then ensures that STUR is a parallelogram? Since STUR is a quadrilateral and both pairs of opposite sides are congruent, then STUR is a parallelogram. Then how can Max be sure that the measure of each corner is 90? Since the diagonals of the parallelogram are congruent, STUR must be a rectangle. In our final example, we're given a proof. Given segment BC is congruent to segment AD, segment BC is perpendicular to segment DC, and segment AD is perpendicular to segment DC, prove that quadrilateral ABCD is a rectangle. Before we can prove ABCD is a rectangle, we have to ensure that ABCD is a parallelogram first. What is the reason that angle ADC is a right angle? Angle ADC is a right angle by the definition of perpendicular lines. Then what is the reason that segment BC is parallel to segment AD? Segment BC is parallel to segment AD because in a plane, if lines are perpendicular to the same line, they're parallel to each other. Then what's the reason that we can say that ABCD is a parallelogram? Since segment BC is congruent to segment AD, and segment BC is parallel to segment AD, then ABCD is a parallelogram. Then what's the reason that ABCD has 4 right angles? From our theorems last week, we noted that if a parallelogram has 1 right angle, then it has 4 right angles. Finally, what is the reason that ABCD is a rectangle? ABCD is a rectangle because of the definition of a rectangle. So that's it for the part 2 video. If you need to rewatch it, take plenty of notes, and we will see you in class tomorrow.